Okay. So during the break, somebody of you asked me, well, okay, we have a synchronization issue. How do we solve it? I didn't get how we solved it. Well, actually, basically, we reduce the problem of synchronization to a problem of serialization. If we have a single API, there's only one outcome. One comes first, and the other arrives second. Okay? And then it's a problem of the server to decide what to do. Okay? And so we solve the problem of synchronizing things, basically saying, well, everything is going to be queued and avoiding the two APIs and putting everything in a single API, we have a clear ordering of the queue, right? It's not like I did something before and now it's my turn and so on. I mean, it's just one API, so either the one arrives first or the other arrives first, and the other one is second, of course. Okay? So just to be clear, maybe I was not clear enough, so I'm sorry about that. Okay, so now we are going to experiment a little bit, right? So you know that in our website on GitHub, you have from yesterday, actually evening, this link exercise on API security that brings you to the usual repository, WA Wix. That's the place where I store all the stuff I do during the lectures, okay? And so in Wix 4, we have a server which is already being prepared, so the code is already there, with an SQL injection example. But just to see an SQL injection once in your life, I would say, okay? Because now, I mean, if you follow the advice, the parametric queries, and so on, it's difficult to have SQL injections, okay? Because they are prevented at the database level, so quite a good way of preventing them, okay? So this example has been constructed on purpose, you know, to allow it. And we will see how it works. Okay? So I take this code. So I already pulled from the repo. So I already have the code here on the PC. And yeah, QA server, buggy, SQL injection. And we see, I mean, the usual stuff. There's a database. The package with the dependency index, and this DAO that basically contains, you know, all the select and stuff implemented as promises to do the operation on the database. Okay? Okay, so first we need to install the packages. So I'm going to show you something as well. I mean, I'm trying to do the clean install. Hope it will fail. Okay, it doesn't work. Okay, I tried it before coming here in the office. It didn't work. I was able to make it work, but I wanted to show you just in case it happens to you as well. Okay. Why does it work? Well, my understanding is that because I prepared it on the Mac and I tested on the Linux. Probably the package lock.json, okay? It's not fine with the hash of the packages, okay? That needs to be downloaded or something like this, okay? So in this case, in any case, I mean, I told you, of course, in big organizations and so on, I mean, there is a repository, probably a private repository where you have a code which has been checked and so on. So these things shouldn't happen, okay? But I mean, we are not so big, and so we try to solve things as we can here. I forgot to attach the power supply. Okay, otherwise lecture will stop in the middle. Okay, so how can we solve it? I mean, just have a look at the dependencies. I mean, my recommendation is just, you know, install the latest version of all dependencies. So here we have DJS, Express, Morgan, SQLite 3. Okay. So, I mean, the node modules is not present, so we don't need to delete anything. We just, delete the package JSON, package log JSON, delete. Okay. I mean, there's nothing wrong in doing this stuff. If you don't have anything really important there, if you have something, make a copy. Okay. But basically, we are using this file just for the list of dependencies, right? So npm init, just give it the name you want. I mean, we don't really care. And this creates a package JSON with an empty list of dependencies. There's no dependencies here, right? And then npm install the JS, Express, Morgan, SQLite 3. Okay. Okay, now it works. Yeah, there's a bit of warnings. We can do anything about this. I mean, there are one package that is used that deprecated packages a dependency of the package itself. So, I mean, either we change the package or we can do anything about that. Okay. So that's a way you can solve this problem. Of course, I mean, it's not really nice from the security point of view because you had a list of packages that were supposed to be used, and actually we changed the version of some packages. Okay, and that's why in big organizations they only have a set of packages that can be used. They have been really thoroughly checked, and for the operating system that is going to be used when the application is deployed, and so on and so on. Okay, but here in our case, I mean, let's say we're trusting the npm repository as a good repository of packages without issues from this point of view, or the point of view of security. Okay, so now basically we can start the server. And the server is in index.js. That's the same name that we will use through the course until the end, and you will use for submitting the project at the exam, so we don't get things wrong. Okay, so there is basically a program to run, right? So there's this index.js at the end, app listen 3001, the port, and the server is listening. So node index.js. Well, yeah, node is fine. Then we can use node mon, but let's keep it for later, because later we will change the server. But not this one. I mean, this one is just a demo. Okay. So the server is ready. Which are the APIs? Actually, I hope I documented the APIs. Yes. Okay, documentation is always welcome. Preview that this format MD is very easy. I mean, new lines and lists and hashes and so on, and you can more or less format a good document. I mean, just with text. It's not mandatory. It's welcome. Let's say. Okay. So this QA server, so the server for a question and answer application, that is the one that will carry on from now through until the end of the course. So basically a place where you can ask questions and put answers, like the Stack Overflow website and so on. Has 3 APIs. Okay, get API questions. There's a list of questions. A list of answers related to a question, a given question ID, and you can insert a new answer. Okay, really basic stuff. I mean, just to show an application, very basic application where you can at least insert something. If we can insert anything, I mean, there's no possibility of injection. Injection means inserting, right? Okay. So the APIs just return the list of questions and answers attached to a question given by an ID, and you send something as a new answer in the body. It's a post, format application JSON, and that's all. Okay, and then well, we could implement something else, but I mean, we don't care. let's try to use this server. I showed it to you very quickly last time, and today we are going to spend more time. Okay, so we have this REST client installed. It's an extension of Visual Studio Code, but as I told you during the lab to somebody of you, you can use any other extension from the browser, from even command line if you like, if you have a program that speaks HTTP, like CURL or wget and so on, okay? Stuff like that. Okay, this one is very convenient because if you create a file .http, it's just a text file. You put a HTTP method, the URL and the version, and you can separate the various URLs with these 3 hashes. And basically, it gives you a sort of button. Actually, it's a text that you can click to run a client that makes this HTTP request, and it shows you in a new window the response. Okay, so let's try. So that's a list of questions. Click, and you see here on the right there's an answer from the server. Okay, so the first line is HTTP, the status 200. Okay, some headers, HTTP headers, we don't really care at this point, except maybe for content type application JSON. Okay, I mean, it's answered in JSON format. And then there's the empty line here, line number 8, and then an array of questions. There's just one question. Okay, this is basic experimentation with an HTTP server implemented with Express and a client. Any client, I don't care about the client. Okay, can be command line, can be a browser, can be an extension of the browser. Okay, it's independent. What's important is it speaks HTTP. Okay, it's not your web application. It's not your React application and so on. You see that there's no React application at this point in the course. Okay, so we don't care about the React application or what you will do in the client. Okay, we're just testing the APIs. Okay, let's test the second one. So that's a list of answers, because then we will add a new answer. Okay, so that's a list of answers. Okay, there are 4 answers. We can also inspect the content of the DB. Just to show you something, let me make some room. Okay, there's this extension that most of you have installed in the lab. We saw it works better than the one that we suggested initially. So this SQLite viewer, just for viewing, probably it works better. Okay, so you click on the DB, and basically it shows you, the content of the various tables. 1 row for the question, 4 rows for the answer, and so on. It's nice because we can see what's actually contained in the DB. Okay, otherwise we need to use the APIs, which is quite inconvenient. Okay, third option, another option. You remember I showed this DB browser for SQLite. That's the name, DB. Oops. Just for the lab, it's useful. One of you asked me here, DB browser for SQLite. That's this stuff, okay? Okay, the network is slow. It's just a standalone program outside Visual Studio Code and so on. Okay, it works in Linux, Windows, Mac, whatever you have. And it's a standalone program. The difference is that you can create a new database, okay? A new DB. And just because somebody of you told me, well, I don't know what to do, to create a new database, just execute SQL, and I gave you, and that's why I give this file, create SQL all data, okay? So it's a text file where basically you define the tables and you put some initial data in the tables, okay? So that's basically a template of what you can use also for the exam when you need to create your own database, okay? Now for simplicity, we give you the database already prepared, but I want to make you independent, okay? So you just, take this SQL, which actually have been exported before by the same program. You run it, okay? You run it, okay, query executed successful, and so on and so on. And then you have your database, okay? And you just, I don't remember, say, write changes, okay? And that's all. And you have your file where you put it. I think it was in home, and you can use it, okay? You just created your database. Okay, that's just a parenthesis. So just a comment about the database. Otherwise, just to look at the content, the Visual Studio Code is enough, more than enough. Good. Now we try to do the risky operation, which is actually adding answers, right? So the third API, it's a post, and it requires to add content, okay? So in particular, text, etc. Okay? So let's try something that works well. Okay, post. Okay. It says 201 created. Why 201? Well, just because I decided this way. Let me see. I can show you. It was a post at a certain point. Here, I put 201. I like that the 201. It could be 200. Okay, I mean, we don't really care too much about this status code. Just use the correct set. Okay, 2 is okay, and 4 is not found or problems, and 5 is internal errors of the server. Okay, and then JSON new ID. So just returned this number. Okay, this is valid JSON, it's just a number. Okay, and that's the new ID that was computed actually by the database. We can have a look at the database. Let me see here. Okay, I don't want to. You see there's a fifth line. This text of the new answer, Bob, etc. That's exactly what we sent from the client, right? Okay, good. And now we try this SQL injection. Okay. Here we have the number. Okay, fine. So we can delete close this window. I don't have that much, so much room here on the screen because I want to keep things big. Okay. And you see, the text now is not, was new answer or something like this. It's some stuff that is looks like an SQL query. Okay. Actually, it's not the query that we saw on the sides, because that one doesn't work. Because the SQLite 3 is smart enough to avoid running 2 queries in a single run operation. Okay, so semicolon, drop, etc. doesn't work. I just tried and it doesn't work. So I had to invent something else. Okay, so this SQL, I searched online a little bit. And basically, you concatenate a second query in the same command without a semicolon. Okay, that's the stuff that stops the rest from being executed. And this is select. So basically, that's an empty string. Okay. So hopefully, in the server code, somebody has opened the string. Okay, and I close the string, and then this or. Select the table name from SQLite master. It's an internal table of SQL where type table and table name not like SQLite something. So I exclude the internal tables, etc. And this is just a comment just to, let's say, sort of terminate the operation. Let's run this operation. Okay. You see, number 6. Good. We inserted a new line in the database. Let's look at the database. What's inside the database? No, let me open here. So you see questions. That's the text of the 6th row, but that's what we sent. Actually, we sent this stuff, okay? And then let's say our application allows to visualize the list of answers, right? I mean, it's normal API get. You see, there's this one with questions. What's questions? Actually, question, that's the name of the table that contains the questions. Okay? So I can get the table, the name of the tables inside the server, because there's this SQL injection possibility. Let's have a look at how was implemented the API. This will subtract point at your exam, okay, if implemented it this way. So create answer, it's in another file. Now it's clearly marked, this is buggy code, don't use it for the exam and so on. You see SQL insert into values, and that's a template literal. I could have used the plus and so on to concatenate a string to the other. I mean, we don't really care the method that we used. I mean, the point is it's not a parametric query, okay? So we constructed a string, and this string, which I also printed console log just for debugging here, so you see what is going to be executed by the server. Insert into value, comma, empty string or select, etc. Okay, so basically the value of this operation, okay, yeah, actually that's a text, that's the last field of the insert, okay, that's a text. So I put the empty string or, so it's sort of undefined or, so basically we have the second value, okay, put into the database. Well, I mean, we are not here to learn how to perform SQL injections, which, by the way, as I told you, I mean, if you're a bit careful on the server side, they don't work anymore today. But just to see if we do wrong things on the server, they can be exploited, okay? And that's a possibility, actually. And just to show you something more interesting, let's see what happens once we know the name of a table, okay? Like, let's say we know that a table is called users, which is actually very common, you know, in web applications. There's plenty of applications that have users, right? So, you know that the developers have a lot of fantasy, so they call the table users. Select password from users where username equal to something. Okay, let's try. Okay, 7. Okay, this post doesn't give you the newly inserted content. Okay, could have been done. So I immediately have the answer. It just insert a new line in the database, a new row, sorry. And then we read the database. Oops, not this one, the answers. Okay? And that's the password of the administrator. Okay? Of course, this was created on purpose, you know, just to show something nice for the lecture. I hope, you know, real websites are not implemented like this. But you see that in the text column of the 7th item in the table answers, there's this admin password, which is actually what was stored here in the user for admin. Okay, so I basically tricked this web server to execute some SQL query that it was designed to take one value from one table to another one, and then I have a way to read the other one with the APIs, like the get. Okay. Of course, I mean, this assumes a lot of things. It's not easy to hack websites, right? It assumes there's a table that is named users, but I saw before we can get a list of names of the tables, okay? And it assumes there's a user that is named admin, okay? So I need to have a username, maybe this of somebody who is important. They can do many things on in the application, and there is this possibility of SQL injection. Okay, so there are many factors. Okay, but if you are weak on some points, maybe this weakness can be exploited in some ways, sometimes just by guessing, right? Okay, so this is more an attack than how to design a web application. But just to show you, these things are real. It can be implemented in practice. That's the only example I think I will give in this course. Okay, where we have something which is really badly implemented, is really vulnerable to attacks and so on. Now that we understood the problem, let's focus more on how to design good APIs. Okay, that is the main purpose of this course. Okay, that's not about to make extremely robust APIs. This course is more avoid the worst errors that you can make with APIs. Okay. Okay, good. So we stop this web server. You have it to try, and we just use the other one. I solved it just for me because sometimes to speed up maybe I need to copy and paste something. So the QA server is what is being published. Okay. Well, let's start from the exercise which I published as well. So let's assume we would like to design an API server. That's what you are going to do in the lab, right? You are going to implement an API server for the film application. Okay, and we have a different application here during lectures, oh no, the QA, yeah, the QA example was described here, right? I hope so. Yeah. Okay. So basically, we have questions and list of answers attached to the question. Could be list of posts and comments and stuff like that. I mean, a simple application where we can insert, delete, and manage things a little bit. Okay. And no, not the README. What's the exercise? Okay. So design and implement an HTTP API server in an Express. We start from this sketch that I gave you. Define a set of HTTP APIs for each common operation on question and answers. Write them in the README file. So we start not from the code, from the README file. We start thinking and designing the API. So the method and the URL. With, of course, in mind what this method and URL should do. And then we try to implement some code that implements our idea. Okay? So for each API, don't forget to define the HTTP method, the URL, with potentially with parameters depending on the type of URL. The request body, if any. If it's just a get, that's no body. If it's a post, of course, you need to give an example at least of what you need to send. And what's the response if there is any response, and the status code in case of success or failure. Okay? And in case of failure, remember you can also give answers through the body, data through the body. For instance, the error type or whatever you want. Okay, and then implement the stuff and well, remember to insert server-side validation of input value, database integrity, and all the good practices that I explained to you today. Okay, and then we can test it with the REST client, etc. Okay. Note, I mean, this note is quite obvious. Like in any programming assignment, there's no single solution. Well, in very simple ones, that's probably the simplest solution. Yes, it's probably most unique. But when the complexity grows, things can be implemented in different ways. The important thing is, if you are unsure, there are the labs, there are the lectures, you can ask me and so on, okay? You're here to learn. The important thing is that you know what you're doing and you have a reason to do what you're doing, okay? In any phase of the design. Okay, so the exercise was, yeah, like adding, finding stuff, and basically listing, which is finding as well. Okay, so let's try to think of what we could do in terms of APIs for our application. Okay, so actually something is already implemented, is basically what we saw before for the SQL injection. So there is already an API for listing all questions. Get is just a list, right? When you get information, I mean, get is enough, that you don't have to do anything particular. I mean, you just get, and if you repeat the get, it's idempotent. It doesn't change anything. I mean, it's not guaranteed that the answer is the same. It's a multi-client application. Somebody else can add the information. Okay, but idempotent doesn't mean the answer is always the same. It means that the effect on the server is always the same. Actually, the get has no effect. Okay, it doesn't change the status of the server. While a post, it might change the status of the server. It adds information typically. Okay, so get API questions, the list of things from which you start in your application. And then there's this get API questions ID. So if you have the ID of a question, you can get all answers related to that question. Because, you know, the database schema, well, it's the one that we saw here. Questions, answers. And if you are unsure, just check directly into the database. Okay, so there's answers. Well, let's say question first. There's ID, text, author, date, and stuff. Answers, ID, text, I think it's respondent, yes, score, date, etc. Okay? Okay, so that's an example of a description of an API. List question, get API questions, get all the questions, none as the request body, response okay or some error. I mean, errors, we can keep them for later, but I mean, you can write them here just for completeness. Response body, an array of objects, each describing a question. Okay, that's fine. Get all the answer to a given question by ID, get API question ID, answer, and so on. Not found, wrong ID. Okay, for instance, here there's an additional case. If the ID is not found, what I'm going to tell the client? So what's the response? It's up to us. I decided to use a different HTTP status code. I mean, not 200, but the 404 not found. Okay? I could also decide it's 200, it's okay, and it's an empty list. It's fine. I don't know. It depends on the application. You need to reason about this. If you can have questions without answers, probably the empty list, you want to keep it for the case where there is no answers, but there is a question. And so you want to differentiate between, no, there's no question with that ID, and the case where the question with that ID exists, but the list of answers is empty. Okay? That's the kind of reasoning that you should do when you design the APIs. You need to think what you need. And maybe you don't get it right at the first time. It's normal. I mean, we are learning, so it's no problem. When you start programming, of course, you make a lot of errors. And so, I mean, just start with a reasonable, let's say, approach. and then in case I need to change something, I go back and change it. Okay? Hopefully I don't have to change too much. Okay, so here, not found. Given the discussion that we just had, I want a different status code. So on the client, I can differentiate the case where there is no question from the case where the question is present but the list of answers is empty. So it will be 200 with the empty list. Okay? And of course the code should reflect this condition. So it should do two different res status depending on what is read from the database. What's the error from the database, if there is an error or not. Okay? Okay, good. Add an answer, that's a post. Request body here has to be described. An object representing an answer, content type application JSON with the various fields. So these names, should match the ones that are written in the code because they are expected in the code. Okay? Of course, the value is just an example, but the previous part, the key, it's expected in the code. It's part of the protocol of the APIs. So the API expects an object with fields, text, respondent, score, etc. Okay? Okay, let's have a look at the code, particular the previous one for ID answers. You see, if results error, I decided for the 404. Otherwise, res JSON, if you put nothing, I mean, the status code is always 200. Okay, that's the default status code. Okay. And this works. Why? Because I designed this function as a promise. You see the await, so there's a promise that gets resolved. It's resolved, not rejected, right? Because the rejected takes us to the catch. Okay, so it's resolved with a value, and the value is an object which has a field error. Okay, let's look at the code. Okay. Hopefully. No, maybe the implementation is wrong. I hope it's... I need to check. But that's what I was expecting. Maybe I didn't test the error. So basically, it's the usual stuff. New promise, DB all, question ID. I need to check what happens if the question ID is not present. I think it just gives an empty array. No, I mean, the where is not satisfied. Well, this leads to think, you know, you think you have a correct implementation, at a certain point you discover you missed something, and then you fix it. I mean, there's nothing wrong in this way of proceeding. Okay, so we need to check better the case of errors, okay? So, okay, this one is for the list, and we have the post API answers. So we created an object answer with the stuff coming from the rec body, so from the client. So just be careful how you use it here. Okay, hopefully, no, that's still the buggy code. Ah, that's a buggy, sorry. We should use the other one. DAO, okay. Yeah, okay, the implementation was the same. This is not buggy anymore, okay? We use the question marks. Okay, so that's a parametric query for the insert. So what we did before doesn't work here. Okay, we just, you know, the whole SQL string gets inserted as text for the answer. You can try it if you like. I think we don't have so much time, so I would like to spend the time on designing the APIs, which is the most difficult thing. So let's try to design an API to delete an answer. Okay? So just copy and paste. Programmers like copy pasting, right? You could ask, the chat GPT stuff, but I mean, let's try not to ask yet, at least for this simple stuff. So, actually, where can I copy from? Well, I will start from the post, okay, which is quite complex. I mean, it's easier to delete stuff than to write stuff, right? So delete an answer. I mean, delete, we have an HTTP method for deleting, so delete, right? API answers, save. Oh, are we? No, I'm just, sorry. I'm writing on the wrong file again. Sometimes it becomes, okay. So that's exactly the same file. I was just in the wrong folder. So copy paste and just delete, okay. So delete, delete answers, and we say when we have delete, we work with APIs that have an ID, because we need to identify the element that we want to delete, okay? ID, okay? This is just text, I mean, just for us, okay? We don't care, less than, greater than, quotation, dot, column ID, whatever, okay? The point, I think it's clear that the last one is a parameter, it's not a fixed string, okay? But this is just documentation, so it doesn't get executed, it's just for reading. It helps us when we are developing. So, description, delete an answer. Delete an answer with a given ID. Okay? Yeah, I think we wrote something like this. Then I will give you at the end of the lecture, a full set of APIs, additional APIs, so you can think and try to develop your own, and then you look for a possible solution. Okay? Request body. Well, actually, there's no body in the delete, right? Just check the slides last time. Right? Delete, put, post, and so on. None. So there's no body to show. Response. I would say 200 okay, right? I mean, when everything goes fine, okay. Or, yeah, generic error. Can you think of other errors that may happen? At the moment, I cannot think anything. Yeah. Okay, the answer does not exist. Good. What are we going to say? I mean, we can say not found. It's fine. Yes. The point is, from the point of view of the application, do we need to know if the answer didn't exist or not? I would say I don't care that much, okay? But that's a personal decision, because in the normal usage of your application, it shouldn't happen that you delete something which is already being deleted, okay? So that's why I don't care, and that's also why we underline the fact there are some methods, HTTP methods, which are idempotent. Delete is one of them. If I perform the delete on the same ID twice, in the end, the result doesn't change. The second time the object to be deleted doesn't exist. It's true. But in the end, it doesn't exist as the first time. Okay? That's why we pointed out this aspect, the idempotent methods. Actually, the only not idempotent method is the post. Okay? Because it changes something on the server. And if you do it twice, you need to be careful. So, I mean, your observation is correct. So, if you want, we can say 404, etc. Okay? since it's more code and we think we are not going to use it on the client side, for the moment I will skip it, okay? But you're free to implement it, okay? I mean, for testing with the REST client, of course, we can send any request, it's fine. But in the end, in the final application, we probably will not ask to delete something that does not exist, okay? So it's more code that we have to write, and I don't expect to use it, so I keep it for later. In case at a certain point I discover, well, I was wrong, I need it, I will write it, okay? So it's something that, let's say, we can put an aside, readme aside, okay? Okay, response body. Well, there's now new created element. I mean, there's really nothing else that we need to say, right? It's true, there can be errors, but we say we don't care about the errors, so I would say none. So the delete is quite simple in general, okay? I just want to, point out that this is a really simple delete operation. It's just one item in the database in one table. You do a delete, SQL delete, it's fine. We solved the problem, right? I mean, these are APIs. So the operation that we are going to do can be more complex, exactly with the same HTTP method. You are deleting a reservation. You are deleting the shopping cart, stuff like that. You define a URL, and what's behind the operation can be more complex, okay? So it's not just one API, one query. By the way, we already saw, the post had two queries, select and insert, right? This is simple. I mean, delete for just one object is fine. But like you are deleting a cart, a shopping cart, you might want to delete many objects in the same table, and maybe you have another table with I don't know, some price, something that was related to the cart. You delete that as well, and so on. With just one API, you need to think in terms of APIs. So operations that make sense from the point of view of your application. Of course, in simple applications, they mostly map on single DB operations, okay? But later on, if you are just curious, you go to the last year's website and you see the example at the end that we did basically the last day of the course. There are more complex APIs, some APIs that requires more operation on the database, okay? But let's stick here, we are just starting to implement APIs, so let's keep things simple. I would like to try to implement this one, vote and answer. You saw that the answers had a score, right? 3, 1, -2, and so on, okay? Don't really care. It's like the Stack Overflow. I'm not sure if you use that website. I mean, there's people posting questions, others posting answers, and users that can up and down vote things, depending on if they like it or not, okay? And the application is more or less the same. But, up voting, down voting, it's interesting from the point of view of the API. That's why I want to implement it. So, okay. So let's go back to the list. And, here we forgot to add it. No. So delete API answers ID, right? So. And then the delete API answers ID, just a list. That's a convenience list for us. And then I need to upvote or downvote a certain answer. Well, it's a certain answer, right? So ID, right? That's an answer, right? Yes. And now what are we going to write here? I mean, in general, I mean, before asking what are we going to write here, it's how does this API work? Okay, that's the first question we should ask. And well, this API identifies an answer by the ID, and then I should go there and say, well, upvote this answer or downvote this answer. Okay, so there should be a way to say up or downvote, and then we need to decide what's the outcome of this API. Does it change the status on the server or not? Does it change the status on the server? Yes. Okay, and then we do it twice. Is the result the same as doing it once? No, because in one case we do +1, in the other case we do +1 + 1, so it's +2, right? So that's an API that changes the status on the server. Post, okay? You're never wrong here. You shouldn't be wrong here, but I mean, if it changes the status of the server, even just potentially, okay? +1, we know for sure it will change. But maybe it's a reservation, and the reservation will not be successful because it's full and so on. We don't care about the fact that actually it didn't change the status, but it has the potential to change, okay? So that's a post, so we need to be careful not to send it again, okay? And so it looks like the other, but I mean, we say that, I mean, this is just a recommendation, okay? So we are entering more in the recommendation part. I mean, writing an API like this, it's not really wrong technically, it can work, but we recommended not to do it because reading it, it seems, create a new answer with a certain ID, okay? Which it doesn't make sense because the ID is decided by the server. So just, you know, add something to the URL, okay? Like vote, upvote, downvote, and so on. We could make two APIs, upvote, downvote. If you like copy pasting, probably you do two APIs. I don't like copy pasting because, you know, programmers, well, apart from the fact they are lazy, you know, copy pasting means that then you modify code in one place and you need to remember to modify code in the other place and so on. So it's a potential source of error. So we'll try to avoid it, okay? So where do we put the information about upvote, downvote? We call it upvote? No. Where do?
If we have upvote and downvote,
yeah.
It's possible concurrency problems.
Yeah, I mean, concurrency is always possible. We cannot avoid it. I mean, we need to be able to handle it, okay? That's the point. I mean, all web applications are subject to concurrency problems because when there is more than one client, what are you going to do? I mean, you cannot just stop the other one, okay? So the point is that you have an operation that have a result, like the vote, that depends on the previous state of the server. You cannot split it into two APIs, like get the vote and then put a new vote, or post a new vote, whatever you want. Because if something happens in the middle, then for concurrency, you don't know what to do, okay? But if you have only one API, I mean, concurrency can always happen. Somebody will arrive first, and the other will arrive second, okay? No problem. If the server needs to perform two operations, the important thing is it performs the two operations correctly, okay? We cannot decide which one arrives first because it's the network that decides which one arrives first. It's the chance, I mean, depending on when you click. The important thing is that given the sequence of operations, the result is correct and it's consistent with the logic of the application. One has said upvote, the other said upvote, the final result must be +2, not +1. Okay, that's the problem of the concurrency. If we implemented the code in a way that sometimes it might happen that you end up with +1 only, even if 2 click the +1, that's wrong. Okay, but in this case, the first will do +1, the second one will do +1, the final result will be +2. Okay? In the case of reservation, the first will get the place and the second one will get nothing. We cannot do nothing. It's like rushing, right? One arrives first and the other arrives second. We cannot really control which one, but it's not up to us. I mean, that's why they tell you hurry up when you are booking something, right? Because if you arrive first, you get the place. The important thing is that you don't give the place to 2 different clients, the same place, because then how do you solve the problem? And here, basically, the point is you don't lose any vote. Okay? So we need to have +2 in case there are 2 requests, regardless of the order. Here, the order doesn't matter, it's the final result that matters. Okay? In the case of the reservation, in the end, something is reserved, but the problem is that somebody else should have been told that you didn't reserve, so you didn't get the place. If you say you got a place to both of the clients, that's a problem. It's a different problem, but I mean, the situation is similar. There are 2 concurrent requests, and you need to make sure that the final result on the server is coherent with the requests that have been done. I cannot decide who wins, but I need to have coherency in the logic of the method. If it's add something, in the end, this stuff should have been added. If it's reserved something, in the end, somebody should get the place. Okay? And that's the only thing we can do. Okay, so I would leave the post this way. Okay? And let's try the description. So, yes, post. Now let me copy and paste again from the post. You see, I'm spending a lot of time on the README. It looks strange, right? I mean, we should be learning how to write code. But if we have, if we don't have clear ideas, it's useless that we start writing code. So description, up vote, down vote, an answer. An answer identified by ID. Identified by ID. Okay. Okay. Where do we write upvote, downvote? Well, that's only another place where you can put information. In the post, either it's in the URL or in the body. Let's define a body that is suitable for our purpose. So that's an object representing the action. Okay? The action. Okay? So, let's say action. That's an example. We decide something. 1, -1, upvote, downvote, whatever you want. Here, that's your protocol. That's the application protocol. You decide what to write here. I like to write upvote. I mean, just because the solution is like this, upvote work less. But I mean, here in theory, I could, write 1 + 1 -1. But then if I get 0, what I'm going to do? That's another thing I need to solve later in the code. Okay? If I get a word which is not valid, like here I should say upvote or downvote. Vote or downvote. Okay? And of course, maybe I took it wrong and maybe you can do plus plus, not plus plus, but you have a bigger plus that adds 2. Well, maybe this API, maybe it's better to change this API and have 1, -1, 2, and -2. So put a number instead of a list of words, okay? So it depends on the case. And then response, I would say there's nothing to be created, so like 200, okay. Service and available, well, this is valid, always valid. Body none, right? Well, actually, that's a possibility. Another possibility could be the final value, the actual final vote, okay? If you like it, that's fine, no problem. I mean, in most of the applications, when you do a modification that changes the server status, in the end, you reload the information from the server. So returning the information here as possible, fine. We will see that in our application, typically we end up reloading everything. So, I mean, yeah, we can put it, but then we will not use it, okay? Third possibility here, just to conclude the discussion. What I'm going to do if I ask for action Enrico, action don't know, whatever string you might think, okay? Well, you can say, well, instead of 200, return something else. There's 500. 500, I like to keep the 500 for server errors, okay? So there's the 400 series of errors. That's useful to know. There's like 422. That's just an example. I mean, we don't really care about the error codes. We just care about the fact that they are in the correct range, let's say, because they are semantic operations. So this is the unprocessable entity. Processable entity. So it's a validation error. So it means I was not able on the server side to understand the request. Okay, you can check HTTP status codes 422. Yeah, unprocessable entity. You see the list. I'm a teapot. Well, sometimes they joke, but I mean, there can be other useful. Well, the 404, of course. 403 forbidden for later. For things that are not authorized. You could have a bad request, generic bad request. 400 is still fine. I mean, you don't really need to be so specific. I mean, if something like this happens, it's typically because you have either a bug in your client application, and so you need to fix the bug, or the request didn't come from your application, but at that point, you don't really care. I mean, it's somebody else trying to use your APIs, and of course, you cannot do so much. You just refuse to do the operation, okay? What's the time? Yeah, it's a bit late. So, we will terminate the example next time, maybe. In any case, maybe I start to put a partial solution, okay? I will show you, so I will commit at the end of the lecture when I'm back in the office, like the implementation for the delete, okay? Really simple stuff. The only thing I would like to show, and I think at this point we will do it next time, is do minimal validation. Okay, so checking the ID is an integer because our database expects the ID to be an integer, or maybe, the vote is upvote, downvote, and stuff like that. Okay. So I will stop here. I mean, note that we spent a lot of time on the README. Okay, I'm expecting you to do the same. I don't want to say in the lab, but for the exam. Okay, that's the first thing we check. That's the first thing that gives us the impression of what you did in the project. And also, that's the first place where you should start writing things, because you are thinking about how to make the application work. Okay? So really, APIs are the most important part that you should learn here in this course. Okay? And then, of course, a little bit of how to develop client application, but we have time for that. Any questions? No? So we can meet, well, there's a lab for the other group tomorrow afternoon with my colleague, and then we will meet on Monday, okay? 1 p.m. usual room. Okay, thank you.